wants to display what's on the room, but how do we know what boxes and what colors they are? So at this point, we don't have anything. So first we join the channel, and this is going to be a a room channel. It's a Elixir Gen server. It will query the database for, okay, give me all the data for the room, for this particular room. So that might include boxes or any sort of geometry. And then we will return a one-time entity's state. And this is one JSON object with all the entity IDs and all the components like color and position and rotation. And then our client can render that on the page. So this is what we have so far. We open our browser, we click on it, we join the channel, and we get some initial state of data. And the same thing happens for client two. So if client two, it's the same thing. It's going to join the channel. The server, the Gen server will query the database, get that JSON data, and push that down to the client. So client two will see the same thing. We'll see this room with boxes that are different colors. Now, what we want to do in today's chapter is we want to continuously update both clients with the changes. So entity's state is what I'm calling the first message that you get, saying, this is what's currently in the room. And then thereon after, you'll get entity's diff messages, which is, this is what's changed. So it's also JSON, but it might have an operation like remove this entity or update this entity or insert this new entity. So in this example, client one moved. Let's say client two didn't do anything. So client one moved, which means that the client one is also an entity, and it has a component like position. So when it says I moved, that might translate into update the component position and rotation on this entity. And so that's a update operation. So the server translates it into this entity's diff message and pushes that to every client, every connected client. So we get a copy of it, client two gets a copy of it, and then it syncs those changes to the database. So if there's a third client that now joins and also does the join channel, the server will query the updated database, and it'll get the updated position of all the entities, including the client one that had moved, and it will get the latest entity state. Whereas every existing client, they don't get entity state any again because they only get that when they first join, but they will have received every entity's diff. If we only sent the one or the other one, then the next joining client wouldn't get the full picture, right? So if client three joins at this point out here, any entity's diff messages that came beforehand, like it wouldn't have gotten those because it hadn't joined the channel. You can only get these messages if you join the channel first, right? So it would have missed all these messages. So that means that we have to update this state and put it in the database somewhere so that the next clients that join, they're not missing out on the new positions or any new geometry or content that has been added to the room.
Is client means user, new user. Is that right?
Yeah, you can
Oh,
think of
okay.
it as user or browser. It's somebody who's connected to the room.
Mm.
Yeah, good question. So, in this lesson, we'll sort of define what the events will be. And I'm calling these sort of domain events, meaning um, when you send messages to the server, I don't use the language of like entity and component. I kind of just say, hey, this is a thing that happened, and here's a payload that goes with it. So here's some examples. Like this is about somebody joining a room, he moves around and he leaves. So you see the event name here is like very easy to understand. User joined, user moved, user left, and then the payload is okay, who joined? Okay, user Bob joined. And then where did they join it? Okay, they joined at this position and rotation. So if you were to receive this message, you might think, oh, okay, I need to draw a new avatar, label it Bob, and put it at this position and rotation. And you could do other things with this message, right? When a user joins, you could like ring a bell, or you could, maybe send some text to if they're not facing the door or whatever, you could just send some text. Hey, user Bob joined the room or whatever. So there's any number of things that you could do with this. Then user moved. So here's another message just to tell the server, hey, user moved. And again, these are pieces of data, and sometimes they align with components, but not always, because they could be more than one message, more than one component that you produce out of these things. So anyway, this is one way of designing this. You may not agree with it because you have to sort of translate it, and this might be kind of cumbersome. But it does mean that this is kind of component agnostic. Like it doesn't really know about what these things are used for. We just want to publish them, and anyone who subscribes to them can interpret them however they want. So it's rather flexible. So these are messages we want to push, such as like I moved or user moved. These are some examples. Then we want to translate them into this entities diff. So in this example here, let's say that we call these domain events or room events. And here's a message that said, okay, a user joined, and we can translate that into a diff event. So a diff is going to be one of three operations. It's going to be either a create, or it's going to be an update, or it's going to be a delete. So if you're familiar with database operations, it's very much CRUD, like create, read, update, delete, very much similar to that. So so the incoming message is always going to have two keys, an event and a payload, but an outgoing entities diff event will always have one key of creates or updates or deletes, and then the payload will be the key will be the entity ID, and then the value would be whatever components. So here they happen to share the same thing. So we're just copying the head position, head rotation into the outgoing component. And here's a user left event. So here the event is user left. Who left? Well, user 1, 2, 3, ABC. And that translates into an entities diff event, which means deletes. So we want to delete this entity. And in this case, we don't really care what the component is because we're just going to remove that avatar from the scene. So we're not really updating their position rotation, and that part doesn't really matter to us. So I just put an empty object here. Um, let's see. Yeah, here's maybe a more interesting example is that by separating the incoming event and the outgoing entity's diff event, like you might think it's sort of cumbersome to do that, and it is, but the trade-off is that they're not coupled together. So here, if you're thinking about like drawing on a board, we could produce an event like the marker when it hits the whiteboard, you could say stroke start. It's the beginning of you adding drawing coordinates, right? So you could say, here's the stroke ID, which is some random number for the current like path that I'm drawing, the color that I'm using, the board that I'm drawing on, and maybe the user ID of who I am. And then you could produce more events following that you are continuing drawing. So you're just accumulating new points, right? So you started with your marker down on the pad and you're drawing some points. And as you move your marker around, you produce new points. And then when you're done, you can emit an event like stroke end. But in the outgoing event, we can like maybe gather them together. Like we don't have to send each of these points over, or perhaps they're all the same entity because the entity that you're updating is just this. So you just keep like replacing that. So it's a single update event or a single update diff that may or may not be similar to the incoming events. So just by separating them together, you have this ability to transform it into something that's more efficient. Another thing is like user movement. So when we move, if you have, let's say 10, 20 people in the room, they're all sending like user moved events, you get a lot of little packets of data with a lot of minor changes. So if we just sent them straight through, then if you had 10, 20 incoming messages, each person would have 10, 20 outgoing messages. But if you just sort of bucket them together, you could just have the server broadcast the same message to all connected users as a single big message instead of 20 tiny little messages for each user. So you can batch them together. So by separating them, you get to manipulate them, you get to merge them, you get to transform them. So there's some advantage for that. The disadvantage is that you have to like implement this transformation. So then we kind of go into the implementation. So Phoenix comes with this thing called Phoenix PubSub, and it allows one part of code to talk to another part of code with an event bus, and it's very easy to do. In some Phoenix code, you would just use PubSub subscribe, and this is the name of the project. So for me, the project is called XR PubSub, and then you give it some topic. So this can be any string that you want. And for us, it would be I think stream colon and then the name of our room ID. And then if it's subscribed, this surrounding piece of code gets a uh, incoming message. So anytime anything publishes messages to this topic, this thing will get an incoming message. So here, the following code checks the mailbox. So Elixir comes with every process having its own mailbox. So the self is my own process ID. Process info means check my incoming messages, and the result is an empty mailbox. So we subscribed, we see that the mailbox is empty, but now we're going to, like any process can do this, we're going to broadcast, which means send a new message to that topic. And then this can be any sort of Elixir term. So here, this is looks like it's a tuple of event name and a payload. And then if we check our mailbox again, we see that we did receive in messages, there is one element now inside the list, and it is that tuple with the event name and the payload. So what you send in will get out. And that's one way of us being able to create these tiny servers inside Elixir that are subscribed to these incoming events that we want to push to it. And so that gives it an opportunity to respond to it. So we just have to write some handler code that, oh, I got a new event. So this is user moved. And I want to change that into a new shape. So here's an example of a gen server code. If you create a file and drop this code in there, this is a very minimal gen server code. So it uses this, I think this is called a behavior. It uses the use gen server behavior, which means that it's almost kind of like a mix in or something. So it adds behavior to this module that we don't actually see under here. At compile time, it will expand it into more code that we're not seeing here. And then we're also utilizing that pub sub that I just demonstrated. Every gen server has this start link that just I guess it's like an internal API that will start a gen server for it. And then the first thing, okay, so you'll start it calling this, and then this thing will call its internal API, passing in this tuple, which is an OK in a room, and it matches this thing. So all you need to do is that you define this, and this is the internal API that gets called. And then the first thing we do is we subscribe to that pub sub, and we're calling it room stream with the room ID. So any messages that come in on this topic, we will receive in our handlers. And then so it's poised to do something. So we have this handler that doesn't do anything, but it's prepared to receive events of this shape. So anytime you publish something on this pub sub topic with this sort of shape that is in this case, it's a map with two keys, event and payload, and then destructures the event and payload in order to do something with that. But this boilerplate code doesn't do anything with it. It's just an example. This is an example of how you start that gen server. So if you did define this, then in your Elixir terminal, you could start it. You call start link and you would get an OK with a process ID. So now that's a little server that's just running with a process, almost like you're running on a Linux terminal or something. You have these processes that your operating system is managing, but this is all happening in the Elixir runtime. So you get this process that similarly to Linux, you can kill, you can send it a kill message. You can,
So Elixir is pretty much kind of like a environment that allows Mac system to run Elixir, to run Linux.
mm, no, um, Elixir is based on, is a, well, I guess we should say the Erlang virtual machine has a runtime,
Mm.
which has processes. So we're not talking about Linux processes, but they are very similar to those processes. Now, so Elixir is a language that compiles to the Erlang virtual machine, and it can run on different sort of platforms. It can run on Linux, it can run on Windows, it can run on Mac. So you can run it on different operating systems, but it itself is a runtime that I'm saying behaves like an operating system because this code here runs like a process and you can start a new process doing this. And if you ran it twice, you would get like two different processes. And then you could even inspect those processes, see how much memory they're using. You can shut down a process. You can supervise them so that when one crashes, it automatically starts it up. So it has this sort of very robust ecosystem of preventing system-wide crashes. So it's the kind of the only language that I know that's modeled this way. It's very cool. So here's an example where we start the gen server again, and on the left we pattern match, which means the process ID here is assigned into this variable PID. And then we can get the state of the PID, and then it will tell you like what data is in it. So if you call get state, it's just this thing. And I think that happens because the init function, if it returns a tuple, so there's all kinds of patterns here that um, are kind of conventions for it. When you return OK, you can pass in the state. So here we're just storing a map with the key of room ID and the value of the room ID. So if we ask it for the state, this is what comes out. But you can modify this. So anytime you handle an event, you, by convention, return like no reply and a new state. That means that you can do work in here and you can modify the state and you store it back in here so that if somebody else calls get state, you can get the new state. So each process is like a running server with its own independent memory. ETS table, this is an Erlang term storage, is an abstraction over a simple key value store. It's also powered by processes, except it gives you maybe sort of a database like API. Not like SQL, it's still kind of a strange key value store, but this is how you use it. And I sort of give through some examples of using it here so that we can store um, the entity's diff messages so that our outgoing messages only happen at a frequency of, a couple times per second, like maybe every 200 milliseconds, so that we can sort of batch the outgoing messages. So I'm using the table to do that. So here you can define a new table using ETS new and then some atom. This isn't even used really, but you can say that it's a set, which means that every element that you want to store in the table is unique. And so there's no duplications. And then it's public, meaning any process could write to it. It allows concurrent write and current read. So this is some options that you can pass to the entities table sort of constructor here. So once you have a reference to the table, then you can insert, and the API for insertion is this two-element tuple, which is the key and some value we want to store. And then to pull this value out, you would just say ETS lookup, provide the reference to the table, and provide the key, and you get back all the values that match this key. And since it's a set, you'll only get one, but you'll get back a list with a tuple of the key and the value that you inserted. You can also dump the whole table out. So if you just say table to list, it will dump out every key, a list of every key and value in it. So that's pretty much the extent of that ETS API. So here I'm demonstrating how to use the room event to ETS table. So here we're going to write a function that will insert into the table for us. So this function takes an entity ID, an operation, meaning like, suppose somebody entered the room. You could say, okay, the person's ID, maybe Tom. The operation, because they just entered the room, should be create. So the operation must be one of these atoms. In Elixir, these are called, I think these are called atoms. Atoms or symbols, I can't remember. I think they're called atoms. And then a payload. So this would be like their position or rotation, and then a reference to that ETS table. So in here, we are looking it up in that table. If it returns empty, which means it didn't exist in the table, then um, we will basically construct a value. So here we're just saying, take this map and then put it into this other. Oh, no. We're saying put into a map the operation which was create and put this map into it, into the payload. So payload, I guess, is the payload you want to put into it, and then we insert that into the database. If it already existed, then you're just updating it. So this thing will continuously update that ETS table. And then finally, here's some functions for grabbing this data out and putting it in a format that will sync out to all the connected clients. This is just some tests that you can run against some data to see what those functions do. So I've packaged this up into utilities, and here's a test for the utilities. So you can see that it inserts a state change. So here we create a new table and we use a utilities function and we say, okay, we're going to insert that person ABC create at this position, put it in the table, and then we pull it back out. So we go table to list with the reference to the table, and we assert that we can get that back. So here we're saying, since it only had one kind of operation on it, which is create, it returns a map of all three keys. So here's the create that happened. It wasn't updated and it wasn't deleted. So these are nil values. Here's another one where something was created and then it was deleted. So we create a new table. We say that we call this function to update that database saying that, okay, ABC was created at this position, and we assert that, yeah, we can get that data back. But then we also insert that, oh, XYZ, they were deleted. And so if we get data from the table again, we get that the creates are ABC, and the deletes are this. So that you're getting back this whole big object that says all the creates are grouped together, all the updates are grouped together, and all the deletes are grouped together. So that's our diff, is this sort of big group of things that have happened for all sort of grouped together by operation, then grouped together by entity ID. And then what follows is whatever components related to the entity in order for you to update the front end.
There's a audience, Armin. He asked, do you have samples for Unity multiplayer using C Sharp?
Uh, I don't. So this is sort of Unity agnostic. This is just the web server side language for doing this.
Um, Armin, as far as I know, that I went to GDC this year, a few weeks ago, and I saw the version SDK, Meta SDK 65. They reveal at GDC. So Meta SDK 65 has the building blocks for multiplayer. So if you want to build a multiplayer, right now is 63, so are still two versions to go. So as far as I know, the internal version 65 has, so you probably need to wait. Yeah, so that's just a question, and I will reply it. Yeah, so yeah, feel free to go ahead. I just there's somebody asked, and right now we have 18 people watch live, so.
Cool. So yeah, this is totally one way of doing it. It's like a homegrown version of message passing. So Elixir lets you define your own messages. So if you find certain ways of optimization, it's definitely not the most optimized because we're still sending things in sort of JSON-like-esque. And if you really wanted to get close to the metal, you could send binary data in UDC packets, right? But this is sort of like a web person's approach to sending messages, which is it's JSON-y. This is what does the translation. So when we get the incoming message of a user joined, then we insert that into the ETS table for each kind. So this is sort of the tax that you pay for being able to translate an incoming message into an entity's diff, is that for every incoming message, you need a handling function in order to determine what the operation is. Here it's user joined. We have to know that that's a create. Here's a user left. We have to know that that translates into a delete. Here's a user moved. We have to translate that into an update. And for one-to-one kind of things, it seems like it doesn't make too much sense here, or it's maybe an annoyance. But if it is one-to-one, it's not that much work. But the dividends, I think, will pay off if it's not one-to-one. If you say that something happened and you're actually doing more manipulation, that maybe this function would make more sense. Finally, we create this entities diff gen server. So here we subscribed, we create the ets table. So we're flushing out that skeleton gen server that we saw earlier, and we're reacting to all the incoming events for here. And then we process the event, which means it puts it into the ETS table. But one thing that's interesting that happened is as soon as we were initialized, we sent ourselves a message of sync. And then that's also going to end up in our own mailbox. And so that's kind of like a ticking scheduler. So every sync interval, which I put at 200 milliseconds here, it will call ourselves, in which case we will just schedule ourselves another sync interval first, and then we'll also query the ETS table to get the transformed JSON object with these all the creates, all the updates, all the deletes, and we're going to broadcast that out to every connected person on the WebSockets through the room channel. and then we clear the ETS table. So every 200 seconds, we're flushing that database. So any incoming messages, they're gathered for 200 milliseconds, and then we flush it out. We just push it out. A gen server wouldn't be complete if you didn't supervise it. So here we're creating a dynamic supervisor, which this just loads another process that watches this process, because every room that we create is going to be a process. So if it dies or crashes, this supervisor will actually start it back up. So this is its strategy, one for one. If you have a gen server that dies, bring it back up. So you'll lose the memory that was in that gen server, which is only sensitive for up to 200 milliseconds, but you get resiliency, like your app won't crash. Just that gen server for that room will crash. Okay. And then this is just how you want to add that to the children and the application so that your room supervisor is started up. And then you would invoke creating your room server to start the room whenever in the room channel when somebody joins the channel, we'll just make sure that that room server is started up. And finally, we add some registry so that we don't have to use the process IDs. We can use string names to search for process IDs. So on a single machine, there's something called a registry. And right now we're just using a single machine. We don't have like multiple distributed nodes yet for that. Elixir has some solutions for a distributed registry, but that API is somewhat more complicated. So I just went for a simple demonstration for now. And so we can when we create the room, if you use this pattern, it's called a via tuple pattern, then we can give our gen server a name. So we're just naming it after the room ID with the prefix of entities diff. All right, and then we're gonna update the entity state with changes. Okay, so this one is about broadcasting the initial state. Is it? Let's listen to them. Oh, I think this is about updating the server. So the server is going to also listen. So every client is listening for entities diff, and they're going to update the Babylon.js in the front end. But we also need to update the backend database because anyone who joins later, they're going to query the database. And if they don't see the updates, then they'll be out of sync. So in the backend, we also make we're going to consume our own entities diff messages and update the database. So I think that's what this does, is that we're going to add a function to the rooms context called update entities. It's going to take the room ID and any incoming message, which is that large JSON-like object of all the creates, all the updates, all the deletes, and it's going to save it to the database. Okay, backend server, let's publish this to the topic. I think I already did this before, right? What's new here? Broadcast, sub broadcast. Oh, okay. I see. It broadcasts, we added this. It broadcasts on another pub sub topic, which this one listens to. So this one subscribes, and then when it gets those, it will save those to the database. Okay, so there's a lot of like complicated backend backend stuff in this chapter. So are you ready, Dom? We'll see how far we get. We've got till 6:30,
And
so that gives you like 20 minutes.
okay,
Let's see what you can do.
okay, cool.
Any other questions?
Um,
Did that make sense? It's a lot of
uh,
back-end program
yeah,
message pattern.
it's like for me, I think my level is more like a um yeah, I mean just just look up and learn what to do. Oh shit. I think give me a sec. Oh, you know what? I
Hmm?
accidentally to close the live streaming.
Just now.
Yeah, just now. Because I wanna get into my screen.
Oh.
What should I do? Should I reconnect? Yes. Just accidentally, I wanna clean up my window. Uh, yeah, I mean, we can work on something. I think you pretty much explained a lot. So maybe what we can do is I will, uh, we still work on this and ask people to watch our video. Because live streaming, it seems like I was trying to answer the questions that Armin asked, just when you were kind of doing your lecturing. And then he was asking pretty much all about Unity. So yeah, hey, give me a sec. Is this still on? Um, yeah, I think it's still on though. Okay, never mind. I think we are still on live streaming. So I need to know. Give me a sec. Yeah. Okay, I think we are still on. So yeah, let's keep working on it. Yeah. Okay, cool. So I will share my screen and see if things changes. I think we're still on. Mm,
Yeah, I still see live on
yes. Okay.
live streaming on my end.
Okay. Great. Great. Yeah. Okay. So, yes, I see my screen. That's great. Okay. So, yeah, I need to do Docker. Give me a sec. Right. Oh, uh, Docker, right? And oh, this one. Docker. Yeah, do Docker first. And then it's running. Name this one. Okay, so today we are going to talk about this entire chapter 7, right? Kind of
Yeah.
forget. Okay, so push entity state entity room channel. Go to room channel. Room and channel.
So this chapter isn't one that you can just copy and paste.
Oh,
So
wow, that is hard. Okay.
so these are these are sort of teaching you what's happening.
Oh,
So it's telling you that this happens, and here's an example,
hmm.
but you can't just paste them into files.
Mm,
Just scroll down. So
mm.
let's scroll down to the first place where you can actually copy and paste something. Keep
Yeah, I mean, for this entire book, it's pretty much copy and paste and
go
read
down,
something and trying to know something, but copy and paste.
scroll down, scroll
Okay.
down, keep going. I'll tell you when to stop.
Okay.
Keep going.
Oh, how do you make like a red highlight?
It doesn't show, that's GitHub. It doesn't show up red on mine.
Oh,
Keep going, keep
mm,
going, keep going,
mm,
keep going, keep going. Go down some more. Go to the
mm.
next, go to the next like example block. Keep going.
Oh,
Skip this. This
ETS.
is
No.
educational still.
Oh, education. Okay. This one
Even um
around here. Room event to ETS table function.
and scroll down some more. I wonder if
Oh,
I provide a full example later. Keep going. Entities, div. Okay, I guess I don't put both of these functions. Okay, okay. All right, create a file right there. libxrutils.
oh, create this file.
Create that. Well, Yeah, create that file, but call it lib/xr/utils.ex.
.ex.
Yeah,
This
I don't
this
know why I
one
called it. I don't know why I called it a class. It's actually a module. So the
module. Okay,
instructions,
.ex.
the instructions could use improving, but create that file first.
Okay, so under which folder?
Here, I'll talk you through it. So you got to listen to me.
Okay.
Lib/xr at
Slash
the top. It's at the top level
libs/xr. Hmm.
right there.
Oh, here. /xr/utility.
So create the file. Oh, actually, it's right there. Utils. Open up utils.
Oh, util. Oh, here. This one.
Yeah. Okay, so add those functions into this file. So,
Add those functions into this file. Also,
yeah.
copy and paste this one.
No. That's
Should I
no,
replace it?
no. That's the test file. Scroll
Oh,
up. Scroll up.
oh,
Okay,
so
so this block and the one above it,
hmm.
you want to grab those and paste it into that file.
Oh, so this one, right?
Yeah,
This one, entire thing
yeah.
need to probably here,
Yeah. And do the one above it too.
one above it, two,
And
one
scroll
above.
up. Yeah,
This
just
one,
grab that.
insert. Oh,
Grab it.
so I need to probably, do you want me to put on top or,
It doesn't matter as long as you don't do it inside a function. It's just going to be outside functions.
oh, it's a function. Okay.
Yeah. Okay, and save it.
Oh,
Okay,
mm,
so you have the functions that we'll be able to insert into an ETS table. Okay, scroll down.
oh,
Okay, here's the test, which, yeah, I guess we could skip the test. Hold on, scroll up a little bit. What is
oh,
this thing? This is, see me. Okay, yeah, follow this instruction. So create a file at libxr room events state mutation, and then
oh.
drop that content in.
So I need to create this file, right? This,
Mm, mhm.
um, oh,
Yeah.
which one, where should I put this file?
Um, you got to create a folder. So libxr room events, create that folder.
Room, room event. Oh, so under libxr.
Yeah,
Okay, so I need to create a new file.
new folder.
Eh, what?
Create a folder
Oh, okay. Libxr, create a new folder.
called
Code,
room events.
oh, room events. This
Yeah,
one? Okay.
yeah. And in there, create a file called state mutation
Date.
dot ex. Yep.
Okay, this one.
And, and now you can paste the content.
Oh, this one. Okay.
All right, save it.
Mm,
Okay. Now we can go back to the book. Scroll down.
to the book. Oh, okay. Come in this. And go back to the book, scroll down, update, entity div,
So I think you
gens.
can grab this whole thing and yeah, paste this into a file under lib servers. Yeah, create a folder under libxr servers and then paste this.
Lib xr, create a folder called server.
Yeah,
Okay.
servers.
Servers. Okay. Ser like this.
Yeah, and then create a file under servers, entities underscore diff.
And the T underscore. What's that?
underscore diff.
Underscore
Yeah.
div. This one. Dot
Yeah.
ex.
And then paste that file.
No, paste this file.
Save that.
Mm.
Okay. And keep going.
Oh,
Keep going. All right. Create the room supervisor in your servers.
this one.
Yeah.
Where? This one?
Under servers, create room supervisor as a file.
Under server. Under service, right? Service. Create a room supervisor.
.ex. Yeah. And paste that. Okay. And scroll down. And then in application, you want to add a reference to this room supervisor. So
Location.
grab that one line there,
This one?
just the line, the yellow line,
Oh, this one.
and go to application.ex and paste it.
Application.ex. Here. The name.
So
Children.
see where there's children, add that at the end of children with a comma before it.
Where's the children? Eh? Oh, here. Right.
Yeah,
Oh.
put it at the end.
Mm,
But you need a
right.
comma. You need a comma.
Comma. Uh, oh, like that.
No, put it at the end of endpoint. It's a list of comma separated things. There you go. Save it. Okay, and then follow the instruction on the next step.
Now we can use the room supervisor to create our entities div gen server when we join the room channel. Update the room channel join function to look like this. So I need to see room channel, room channel, room channel. Oh, this one,
Yes.
room channel,
There's a
join
join.
function, this one,
Mhm.
make this one look like this one. So what I need to do is maybe just copy and paste.
Yeah, okay.
Okay. So what I did was I add this supervisor star room, something like that. The supervisor server room supervisor thing, star room ID send self after join. Okay. This starts the entity div gen server if it hasn't already started. Yeah, we also want to be able to stop gen server in case. Add local registry for unique gen server names. Unnamed right now, so we cannot talk to it. The registry inserts a mapping between the name and a PID. Create a registry by adding this line in the application.ex list after endpoint. There's something children. Let me see. Applications.ex. Applications.ex. This one. And there's like a lot of endpoint for children. This one. Then
So just grab that line.
grab this one, and at the end, this one.
Yep.
Oh,
But Put a comma and save it. Okay. And you need
Now, mm,
to
now we can name each process that is created from any Gen server we create using by tuple. API add this by tuple function to our Gen server. So add by. So this is by two. Where should I put?
just grab that function there that's via tuple, not the whole thing, just the
Oh,
function that's via tuple.
oh, the function, two functions.
Yeah, but that's just to tell you where it is in the file, where I want you to put it in the file. You only need to add the via tuple function to the file.
Oh, this one.
Yes.
Oh, so via tuple function. To put in XR servers. This one,
Put it
entity div.
in the entities diff. Just
This
right
one, entity div. Uh,
Just put it at the top
at the top. Okay, put it at the top.
after pub sub or yeah, you can put it there.
Okay.
Okay, and save
Mm.
it.
So now when we start that Gen server, its PID is registered in the registry. Let's also add a stop room function to the room supervisor. Okay, so let's start that Gen server registry. Add a stop room function to the room supervisor. So there's a room supervisor, this one, and I need to add stop room function. So stop room function. So start room, maybe after this, and stop room. This one.
Mhm.
Okay. Update entity state with changes. We can now message entity underscore div changes to the front end, whenever something happens in the room that changes state. However, we need to persist those changes into our database. Otherwise, our entity state message will be stale. Let's create a new server that will listen to entity underscore div messages, create a new server file at, under the servers, XR under servers, this one, under this one, I need to create something called entity state, right? Entity state. File. Entity state.ex. And create a new server file and copy and paste these things. Listen to entity.
Oh,
Okay, this one. This server subscribe to a purpose subtopic of entity state room ID back in entity underscore div server. That's published topic. So entity div. That's publish this topic. So probably just go at the end.
don't paste the whole thing. I think. Well, actually, oh, okay, yeah, yes, do paste the whole thing.
Oh,
Wait,
okay.
wait, is that right? Do you have
Okay.
another sync function in here? This is entities. Oh, wait. This is supposed to be in entities diff. No, you pasted it in the wrong place. Undo.
Back. Okay.
Go
So,
to your entity,
div. Okay.
and then I
Entity
think
div.
you do have a sync function in here. So scroll
Oh,
down.
scroll down.
Yeah, you all.
Okay.
Yeah, see, you have a sync function on line 35.
On line 35.
Yeah, so you want to replace this thing.
Oh, give me a sec. Let me see what's going on. I have the handle in here, right?
Mhm.
Okay, so sync state do process send after self sync interval case XR, or
I
I
don't,
just copy and paste this thing.
yeah, I think you should just paste it.
Okay.
Okay. Okay, then you want to supervise both gen servers anytime. Yeah, so you want to modify. I guess you could paste these two functions over the two functions in the room supervisor. Just grab them.
Okay. So room supervisor start room function. So add this room supervisor rooms supervisor here.
Mhm.
Add this one start room function. So it starts the same time as entity. So start room function. So start room function. Start room will be in front of, hey, I've already added this start room. Oh, but they have two. Okay, so start room function need to have two, something like that. Div and state need to be get the same thing. Right? Do you need a dynamic like this stop room?
I already said you could copy the whole thing and paste over those last two functions.
Oh, okay. Mm.
Okay, scroll down in your book.
Okay. Let's write a helper function that takes the entity underscore div payload and saves the changes to the DB.
Okay, so I think I want to copy this whole thing.
Copy this whole thing.
Yeah. Yeah, and then put it inside rooms.ex, I think.
Rooms.ex. Okay. Copy and paste this whole thing. Eh? Update component. So there's no update component. Update, what's that?
First of all, you're in the wrong file. It's rooms.ex, not room.ex. Search it.
Here.
Mm-hmm.
Room.
Just paste it.
Okay, so paste update. Okay, so paste the in component with the yeah.
Save it. Okay. And scroll down. Okay. You're all done.
Copy and paste job done.
Okay.
Cool. Yeah.
That's it. I mean, if you wanted to see output,
Yeah.
you skipped was running the tests and
Oh.
see it persist in the database. But
Hmm.
and you did the work, so you're prepped for next week at least. So let's see what's next week. Next week,
Mm,
after you have that, then
mm,
we can basically implement the user events. So we will cover when you emitting those events, when you join, when
mm,
you move, and when you leave, we'll emit those events. And then we should see in the console log that we're receiving like entities diff events. And then we can write handlers on the front end to like add a box to represent your avatar or delete a box when you leave, stuff like that.
Wow. So right now, still not Babylon.js, right? Need a couple of weeks to get into Babylon.js.
Let's see. And next week, let's see what it is. Basic user events, client entity, feed frequency.
Still connecting to the server.
Yeah, next week is still more. Well, there is some JavaScript stuff, but I
Mm.
don't think we actually do much of Babylon.js next week.
Okay, cool. Yeah, thank you so much for your teaching and I think our maximum live watching was 18 people. Yeah, I will share with you the data. Yeah, thank you so
Cool.
much. Oh, 21 peak live viewers. Wow, cool.
Cool.
Awesome. Thank you so much. Bye bye.